Now, I normally don't do the follow-ups to these questions, but this one's very interesting. Now it's asking determine the smallest force applied at B that creates the same amount about D. So now here's the thing. So how do you find the smallest force? Because we can make any, not any, but there's probably there is a number of forces that could create the same moment. Because let's say we can have a force at this angle or a force at this angle, or just one that's completely in the x and y, right? And they'd all themselves create moments. So what is the angle, the smallest angle, to create the same moment? If I wanted to rotate this and I had to do it at point B, we have a choice now, right? We can do that, or we could do this. I think this one would be easier. Personally. So, just off of intuition, let's see if that would be true. We can just call this F min. And I might very well be wrong, because it might be at an angle. In fact, there's a very good chance that it's at an angle. Do we even need to think about that? Well, we know the moment about D is equal to 42.5 newtons meters. And we know that the moment equals R cross F, right? We know the R, we know what that's going to be, and we're looking for this. So what we do is we have two unknowns or two knowns and one unknown. So we could actually think about it like this. Let's see, we're going to have 200x, and that's going to be counterclockwise, so it's going to be positive. And then we're going to have maybe an x value here, because this was y, it's the variable x, but it's direction y. This pushing it would be so this would be minus 200. Or no. Yeah, it's 200 both ways. Oh, that's oh boy. That doesn't look good, does it? When they just cancel each other out. Interesting. Okay, so it looks to me like this is interesting. This is exactly the dead opposite of what I was advocating. So one way to do this is to look here at this angle, because knowing that the moments about D are going to be equal to the distance times the force. When we want force to be the least we want the distance to be the maximum. Now here's the thing that I don't quite get about that, right? Distance doesn't change no matter what. We are taking it about this point no matter what we do. So the correct way to think about that then is not that we're taking it about a maximum force or a maximum distance all of a sudden. Distance never changes. No matter what we do, distance can't possibly change. So to me, that's just poor thinking. But what that does show is the angle would be perpendicular to this here now. When we want the minimum force, we go from here and we find, well, let's see. This was pushed. This is positive moment. Positive moment means, well, there's no possible way that this force at this angle is going to push it anything but counterclockwise. So yeah, counterclockwise, which means to counteract this, we would have to go down. The force then would be not here. Whoops. We can just forget about that. But it would be here, and we would find this angle. Well, not quite. It would be this angle plus this angle. This could be like theta, and then this could be phi. Screw you, point C. And then this just becomes a 90-degree angle, so then phi equals 90 minus theta. And theta equals, let's see, tan inverse of, let's see, adjacent over hypotenuse. We could just do cosine. Opposite over adjacent. Opposite over adjacent is tan. 200 over 120. Nope, this would also be 200. 200 over 200. Isn't that just 45? The inverse tan of 200 over 200 is straight up 45. And what happened to my John Coltrane record? Okay. So we have an angle of 45 degrees, so 90 minus 45 is 45. Then the angle of R is going to be 45. So now we just need to force, not R, force. So now we just need to find that, well, that force is going to be R cross F. And the distance now would be this. And this is why I don't like this. Because now we're thinking of this as the distance. That distance is going to be the square root of 200 squared plus 200 squared. So that means that the force is going to be equal to the moment over the distance r, because m equals r cross f, we divide both sides by r, and then we get force equals that. So now we can plug moment in as 42.5 and r in as 282.84. And the minimum force required here is now going to be 1.503. That don't seem right. It ain't right. Oh, I wrote this wrong. Somehow worse when I wrote it right, though. What went wrong? Ah, yes, I got it. This was in millimeters. So now we change this over to meters again. And then what was the conversion here? It was 1, 2, 3. And then this becomes 1, 2, 3. Getting 150.3. Seems like a lot. But that is the answer, and this is going to be in newtons meters. So looks like I had the same problem both times. Is recognizing that it's in the answer is in meters. Well, no, they want this in newtons. Force is in newtons. Oh my gosh! But we had to get it in meters because that's what a newton is. And they don't even ask what the angle is. They don't care. So I'm going to assume that angle is correct based on my logic there. But they don't ask it. No, they don't. Okay. So there you go. There you go. It took a little bit longer than I anticipated, but I chose it because it was interesting. So that's that.